Causes of climate. So different areas have different climates. We kind of know that. For example, average temperatures in Dallas, Texas are higher than in Minneapolis, Minnesota. Some causes of climate variations include differences in the following. So latitude, that's our big difference between Dallas, which is down here on the map, and Minneapolis, which is up here. Latitude's different. Minneapolis is further north. Topography, which is sort of hills and valleys and that sort of thing. Proximity of lakes and oceans, so how close are you to the ocean? Global wind patterns, ocean currents, air masses, and the availability of moisture, so how much rain do you get in an area? Those things all affect the climate of an area. Now, the effects of latitude. So, different parts of Earth receive different amounts of solar radiation, and the amount depends on the latitude and varies due to Earth's tilt on its axis. Um, so, the tropics is an area between 23.5 degrees north and 23.5 degrees south latitude. So, this is basically 23.5 degrees north and south of the equator. And these areas receive the most solar radiation annually. So the temperate zones lie between 23.5 degrees and 66.5 degrees north and south of the equator. And these areas get an intermediate amount of solar radiation. And then the polar regions extend from 66.5 degrees north and south to the poles. So these are basically the Arctic and the Antarctic circles, and these receive the least solar radiation annually. So why is that? Well, if we look at our zones of latitude here, we start to get an idea. First off, the Earth is a curved surface, okay? But our tropical zones are right here. So between the Tropic of Cancer at 23.5 degrees north and the Tropic of Capricorn at 23.5 degrees south. So those are the tropics. The temperate zone is basically between the tropics and the Arctic Circle or the Antarctic Circle. And then you have the polar zone. So you have the Arctic zone and the Antarctic zone. And the reason these get different amounts of solar radiation, again, is because the Earth is a curved surface and the sun is basically coming in kind of straight, really, considering how far away the sun is and how big the sun is. So really the sun's rays are coming in almost horizontally here. So they're coming in almost straight. And as you get further from the equator here, then the rays get more and more spread out. But again, here we're talking about the polar zones, the temperate zones, and the tropical zones here, and kind of where they're located. All right. So a better example of how this solar radiation differs depending on latitude, basically it decreases from the equator to the poles. And this right here is kind of showing what I was trying to show on the previous slide, is that the sun's rays come in fairly parallel, but they're more concentrated where they strike at a 90-degree angle. So if you were on the surface of the Earth, the sun would be basically straight overhead and pointed straight down. So you have a 90-degree angle between the sun's rays and the Earth's surface. The sun is very concentrated at that point. As you get further away, say like here, the sun's rays may come in at a 45-degree angle because now they're still coming in kind of parallel, but now the Earth is curving away from the sun here. So those rays hit and they spread out. So you end up with less concentrated solar radiation. And as you get to the poles, you get to lower and lower angles until eventually you get to no sunlight. Once you're sort of beyond the Arctic Circle, there are areas where you would have no sunlight. So like at the pole here, during this time of year, you may have no sunlight. But the angle gets lower and lower as you go further north or south from the equator. Now, Earth's tilt in the tropics. So kind of showing why the tropics are where they are. So at the summer solstice or the June solstice, the sunlight is coming in directly at the Tropic of Cancer. And on the opposite side of the Earth, it's basically hitting the Tropic of Capricorn here. And this is basically as far north as the sun will go and still have a right angle to the Earth's surface. So the Earth's surface would be here. You have a right angle from the sun coming in here. It doesn't do that any further north. You'll never get at where we live here. You'll never get the sun coming in at a perfect 90-degree angle. So that's the summer solstice. And then throughout the year, as the Earth goes around the sun, this shifts until the winter solstice or the December solstice, at which point the sun is coming in at a right angle to the Tropic of Capricorn. So now it would be summer in the southern hemisphere here, winter in the northern hemisphere. But here the sun is actually coming in at a 90-degree angle to the Tropic of Capricorn. And it's the only time that we do that. As far south as you can go and still have the sun come in at a 90-degree angle at some point in time. Now, the effects of topography. So again, topography is mountains and valleys and that sort of thing. But water heats up and cools down more slowly than land. So if we're talking about being close to a body of water, for example, so if you have a lake or the ocean or something like that, the water heats up and cools down more slowly, and this reduces the extremes of temperature near large bodies of water. So if you're near the ocean, the temperature stays fairly constant year-round. Not constant necessarily, but it doesn't get nearly as hot or nearly as cold if you're near a large body of water, because the water will absorb heat in the summer and release heat in the winter. Now, if we're talking about with elevation, temperatures in the lower atmosphere, which is basically where we live, but temperatures decrease with elevation. So mountain climates tend to be cooler, and then there are often different climates on either side of a mountain. So if we have our diagram here, we have the ocean and the direction of the wind. The wind is coming in this way, and basically the wind can't go through the mountain. So what does it do? It has to go up and over the mountain. Well, this is moist air because it's coming off the ocean. We also call this the windward side of the mountain, which is cool and wet. But as the air rises on the windward side of the mountain, it cools, it condenses, and precipitation occurs. So you have a lot of rain falling on this windward side of the mountain. Now, as the air goes up and over the mountain, you'll get some snow on top. But then the air basically dries out as it comes up over top of the mountain, because you've got a lot of rain, and a lot of the moisture will actually fall out of the air as it comes up and over the mountain. But dry air warms as it descends the leeward side of the mountain, commonly resulting in desert conditions. So you have this warm, dry air coming down on the leeward side of the mountain, and you tend to have a desert over here. So if we think about a lot of the deserts southwest, they are just to the east, or they are on the leeward side of the Rocky Mountains. And the effects of air masses. So the movement interaction of air masses is our main cause of weather. So air masses collide with each other, and we get weather from that. This also affects our climate. Now, air masses have properties similar to the areas they form over. Okay, so if they form over water, they're going to have damp air. If they form over land, they're going to have drier air. If they form further north, they're going to be colder. If they form closer to the equator, they're going to be warmer. Okay, now we call these continental if they form over land. So continental air masses form over land. They're maritime air masses if they form over the ocean. Okay, so we have maritime tropical, we have maritime polar, etc. Now, polar that's what we call them if they form close to the poles, and tropical if they form closer to the equator. So you can actually put these together and get 4 different types of air masses. You have continental polar, you have continental tropical, you have maritime polar, and maritime tropical. And you kind of get an idea of what these air masses are based on where they form. So continental polar is going to be cold and dry. Continental tropical is going to be hot and dry. Maritime polar is going to be cold and damp. And then tropical maritime or maritime tropical is going to be warm and damp. Okay. And we have different ones from different areas. So maritime tropical would form out here over the ocean. You have maritime tropical over here. You have maritime polar You have continental polar, you have continental tropical here. You also have Arctic that gets thrown in here too.